Okay, student, I'm sharing a screen with you and also recording the lecture. Okay. Today we'll discussing about network topologies and networking devices, hubs, switches, router, gateway. Basically, it is my first second lecture as per my slide distribution, but I'm taking as a first because idea about what is a network. Basically, a network means what? It is a connection, like Google. What the Google say? Like if you type here computer networking. Yes. Okay. As per the Wikipedia, a computer network is a set of computers sharing resources located or provided by the network load. A computer uses common communication protocol over that. Means what? Basically, we can means what we can assume that networking means what? Computer networking is a set of rules or set of rules means what? Protocols. Set of protocols that will be used to communicate or connect other system or other nodes in that. Okay, other definition will also do. Networking also known as computer networking is the practice of transporting and exchanging the data between nodes means what? Computers or networking devices over shared medium in information system. Okay, networking facilitates everything from telephone calls, text messages, streaming videos to do the IoT things. Okay, the internets of things. Also, we can do this is we call the basic definition of networking. Okay, so as I told that networking is a connection between nodes means what how they set up the connection. It is a basic definition of computer networking. We'll start now. For doing this, for connecting the nodes, we use a number of devices. So we'll firstly discuss about devices, then we'll discuss about how we can connect them. Okay, we have to first discuss the devices that are available in computer networking section. So we start with this. uh, Firstly, I will tell you some of topologies are there. Topology means what? Topology means it is a basically arrangement of network which compromise nodes and connecting the life via receivers or framework or means what? It we call uh, wait a minute. I'm just using whiteboard here. Is this whiteboard visible to you? Okay, so this is a whiteboard that is available in Google Meet. So I'm using this whiteboard here. Uh, Look, this is one of the computer or one of the device. And again, I'm giving an example. Look, this simple example that I want to give you. These are the some nodes, means what computer points are there, means we can also this is your computer devices or mobile devices is there. And this is your server. What is that? This is your server, and all these are connected with, means basically this we call your switch. Basically, if you are working in single lab, so you know that in our lab, in computer lab, there is a switch is there, like a blinking of light is there on that switch. So it shows that the all these computers are connected with a wire to this link. So we have to discuss about uh, what is the switch, how the nodes are given some numbers. Okay, what is that number that we call IP address, how we can assign the IP address, how this wire communicate with switch. Okay, okay, so all these things, what are the protocols that we are using in computer networking, so how they communicate, how the data transfer through the wire, okay, or wireless communication, how the wireless communication done. So all this thing we have to discuss in this data communication and networking chapter. So don't worry about that, I will discuss in detail. So we'll start this. Topology means what? It is an arrangement, means I'm showing you arrangement that how the devices are connected with each other. So it has some arrangement, like if we go in a ground for period, for parade, so you know about that, how the students are arranged. So that's like we have to arrange the devices. So the arrangement of devices we call topology. It has five types of topologies there: mesh topology, star topology, bus topology, ring topology, and hybrid topology is there. Is it any doubt? Anyone having any doubt? No. Okay. Let's continue it. Thank you. Okay. First, one by one, we'll discuss about what is this the mesh, what is star, what is bus, what is ring. Okay. A mesh. Mesh means what? Every devices is connected with an other devices or dedicated channel. This is known as channel. Is known as mesh. Means what? Like here. I'll give an example. If it is here. No. So basically, I will give an example here itself. Like this is your this I just do this one thing, like this node. Okay, this is one of my device. Okay, copy, paste. This is other device. This again, this is another device. Again, this is another device. Okay, these are the nodes. Okay, we have to discuss about mesh. So what is mesh? I'll just tell you. Every device is connected with another via dedicated channel. Means if you are using a mesh topology here, then then each and every device should be connected with each other devices directly. Okay, so I'm here is connecting with this also. Okay, sorry, and this also I'm connecting, means each and every this way also connected. A dedicated channel line is there, means each and every device is connected with each other devices that are available in your network or your connection via special channel. So this we call the mesh. Here again this will be connected to this, then again we having a channel with this link only, this channel, for we also having this, then this one, then this one. Okay, so all this connected, then we'll use for this uh, also the, and this one, for this we'll use this one, then we'll also connect to this, then this one. So all are connected with each other via spatial links, so this we call the mesh. Is it clear, all of you? It is clear? Is it clear? Gitika, no. uh, Gitika, look at this picture. Mesh means what? We have to discuss about topologies. Topologies means what? Arrangement, how the devices are linked together. Okay, so that arrangement we call topology. There are 5 types of arrangement like mesh, star, hybrid. We are discussing one by one. So firstly we discuss about a mesh topology is there. Mesh topology, each devices is connected with other devices via a special type of channel that we call mesh. Is it clear? Yutika, is it clear? Is it anyone having doubt? Yes or no? Please type yes or no. You understand this mesh? Okay, we'll continue it. Every device is connected via other dedicated channel. This channel is known as link. If suppose there are n number of devices that are connected with each other in mesh, then the total number of ports that required by each devices is n minus 1. This will be also a question. Port means what? Connecting device, where we connect the device. So each and every other devices require n minus 1 port. Like here in this device we having 6 nodes is there. Okay, how much devices we require for connecting, or we can call uh, there are number of devices is 6, so port require is 6 minus 1 is 5. Is it clear? We require port how much port we require? 5. Is what? From this, to connect this device to all other devices we require port here, then port here, then port here, then our other require a port. So that we call we require number of ports is n minus 1. If suppose n number of devices are connected with each other in mesh topology, then the total number of dedicated links that are connected is nc2. Okay, means what? If there are 5 or 6 devices are connected
Sir,
with
your
each other,
mic is off.
then
You are not audible.
how many links are used? Then that we call NC2. Okay, permutation and combination. You know about that. What is mean by permutation and combination? But if you not known, then simply remember this formula: n into n minus 1 divided by 2. How many nodes are there? 6 nodes are there, and n minus 1 means what? 5. 6 into 5, 30. 30 divided by 2. That will be a 50 links are available to connect each and every other devices. Okay, total numbers of links, this links, if you count this will be 15 links. Okay, Now getting this point, I will show another example with you. Uh, Consider only 4 nodes are there. Look at here, only 4 devices are there. If I want to connect these devices, so I'm just using here one link. This will be other link, 2. This will be 3. Okay. Then to link this, I require this one link. Then I also require this link. Okay. Uh, Again, to link this one to this, I require this one. So look at here. Each and every other devices are connected via special types of link. If you consider this link, I'm just giving a name here, 1, this 2, this will be 3, and this will be a 4. Okay, so I want to connect with other 2, 3, 4s. I require number of nodes 1, 2, and 3. Links 3. Okay, 4. This will be a 5. If you count number of links are there, 6. Okay, is any other remaining? How much are there? Total 6 are there. Okay, how many nodes are there? 4. 4 into 3, that will be a 12. 4 into 3, okay, divided by 2, that will be a 6. Okay, you're getting how much links are available? 6 links are available. How much ports are available? How much port you require? This we require n minus 1 ports. So for 4 nodes to communicate with each other, we require n minus 1, means 4 minus 1, 3 ports we require. Okay, one port for this 3 node, this second port for this, and 4 port for this. Are you is it you understand this? What is meant by this mesh topology? Is it clear? What is mean by mesh topology? Oh my god. No problem. Sorry, Aniket. Uh, this recorded all the lecture. In that you also get mic is on for recording also. This I will explain again one more time. What is mesh and what is n minus 1 nodes are there. So look at here. I will again explaining you. Sorry, my mic is not. It is mute in condition. I'm just explaining to you. Again, we explain. This we call the mesh. Means each and other devices are connected via special type of link. Okay, that we call the mesh. If suppose there are n number of devices, they are connected via special type of link. The number of links you require is n into n minus 1 divided by 2. Okay, that is the total number of links, and the port that we require to connect each and every other devices is n minus 1. So look at here on this example. If we are having a 4 nodes 1 2 3 4 nodes are there, they are connected with each other via special link. Therefore 1 2 3 4 5 6. Okay, 6 links are there total. How we can calculate? There are 4 means what? N into n means what? 4. Our n is 4 and n minus 1 is 3. So 4 into 3 divided by 2. This is the formula for calculating the numbers of links. If you are having n is equal to 15 nodes are there. How much? 15 nodes are there. Then n minus 1 will be 14, and the links to calculate is n into n minus 1 divided by 2. So it will be 15 into 14 divided by 2. Okay, so what will be the answer? 2 ones are 2, 2 sevens are. Okay, how much? 15 into 7. How much it will be? Is I'm audible? Hello? Is I'm audible?
Yes,
Are
yes,
you getting this point? Yes. If anything happens, means what, my mic is off or voice is breaking, so please reply me in chat box so I will get an okay that message to.
present sir.
Wait a minute. Then how much the answer? 15 into 7. How much it will be? 105, no? Okay, am I right? So there 105 will be your answer. Okay. How much link you require? Special type of links. 105, 105. You require the total number of links for 15 nodes. Okay. Connections are how much port you require? 15 minus 1, that is 14 port you require. Port means what? A connecting socket, that where you plug your cable for connection. That we call port. Is it clear? All of you. All of you. It is clear. Okay, we'll discuss next topic that we call next star topology is there. Star topology means what? It is like a star. In a star topology, all devices are connected to a single hub through a cable. This hub is a central node and all other nodes are connected to central nodes. The hub can be a passive in nature. Passive means what? It is a intelligent hub, or that we receive broadcasting devices at the same time. Hub can be intelligent, how to know the which path and which repeaters we require. Just a simple example I'm showing you. Just look at here. This is our maze topology. Okay. Then we'll discuss about star topology. Star means what? We'll take. Wait a minute. Hello. Yes, sir. Yeah, yeah. Okay. Sorry for disturbance. Is I'm audible? Okay, we'll start now. We are discussing about star topology. Star topology is, I will show with the diagram. You will get a idea of what is that star. Star in star, we are using one device in middle. Means all other devices are connected to this device. Like in our lab, we are using switch. switch and other devices are connected in star topology. What is the advantage of the star topology? The look at here. This we call the switch. This is our switch. Okay. This is our switch. This is our nodes. Means connecting nodes are there. All are the nodes. Okay. How many nodes are there? One, one, two, three, four, four, and four. 8 nodes are there. How much nodes are there? 8 nodes are there. They are connected via a star topology. Star topology means what? They are connected to one of the main devices that we call a hub or switch. Okay. This device may be intelligent. Means what? If I want to share, like this node of this name is A and this node is D. Okay. I want to share some information from A to D. So this switch or hub will help to me set up connection between these two. Okay, A and D. Then a message is come to this switch, and this switch will decide which route the message will be transferred to the D. Okay, the state route is this. Okay, if it is not intelligent device, means what? This switch is not, or this hub is not intelligent device, then it will distribute this all message to all nodes. You're getting this point? This switch will distribute this message to all available nodes that are connected via switch. Okay, you're getting. But if it is intelligent, then it will definitely read the message. Okay, and the destination address, and then it will definitely transfer to the address of D or IP address of the D. I'm getting point. You are getting the point. Thus, there's a very important point here. The device will depend like it is a passive or active. Okay, active hub or it having also repeaters. Repeaters will discuss what is the use of repeater. Just remember it. Just just do one thing. Repeaters means what? It is a device. Look at here. It is a device. Repeater also a device. Okay, repeater, switch, hub. These all are the what devices that are used in connection to nodes. What happens in repeaters? Repeaters mean some message come to the repeater from transferring from this message to this place. It will lose some information like its amplitude value get lost. Means what? Amplitude of it is a somewhat communicable data like digital data, so its amplitude value or its maximum value like decreases. So our devices are so intelligent that they will amplify them. Okay, the signals are get amplified it and then transfer, so that we call the repeaters. The use of that devices we call repeaters. Means what? Signal we are receiving is get amplified and then transfer. After that they will transfer. That devices we call repeaters. So a hub like work as a repeater like switch. Okay, so this is only the star topology we are use here. So uh, also look at here, each device require only one port to communicate to the hub. Means what? One port here, one port here, one port here, one port here, and again a switch having. Means what? If a switch or hub having one port or 12 port or for 24 ports or 48 ports, switches are available in market. So that's only the ports we require. Okay, not like a mesh topology in that if you are having a 6 node, then you require at least n minus 1 nodes, like 5 nodes we require. But in star topology we require only one nodes, because if you want to communicate the, like here, if you want to communicate from A to D, you require only 2 nodes, this and this one. Okay, you're getting this point. Only one node or port is required to communicate. If the concentrator hubs on which the whole files are replicated or files fails, this whole system will crash down. One disadvantage of this system is that if your system is collapsed, means what? Switch or hub, that's all nodes are connected with this device, if get off or get disturbed or get, means what, affected, so all the system will be affected. But not happens to this. Look at here. For this, it will be not happens. Like if this node get, means what, it get affected. Okay. If this node get affected, or communication between this one to two node, means wire this line is get affected, or this wire is get disconnected, the communication still going on. Means what, from two wires to then again four to the six. Okay, we can communicate with this node here, but it will not happens with this mesh topology. Sorry, star topology. If your switch get off, then all the connection with them is also off. Remember this point. Okay. If your middle or concentrator or hub get off, the all system will be collapsed. Is it clear? Then we'll discuss about bus topology. Bus topology is a network type in which every computer and network device is connected to a single cable. It transmits the data from one end to another end. Okay. No bidirectional features in bus topology. If n devices are connected to each other, then in bus topology, the number of cables required to connect them is 1. Okay. The cost of cable is less as compared to topology, but instead of using build small networks. If cable fails, then the whole system will crash down. If the network traffic is heavy, it increases the collision of the network to avoid the various protocols and MAC layer also on pure Aloha and slotted Aloha and CDM. Okay, remember this. This is the important things that we are using here. Bus topology means what? It is a topology uh, network type in which every computer and network device is connected to a single cable. Okay, I will show a graph of bus topology. What is mean of bus topology? Look at here. This is a main cable. This we call the main cable, and on this main cables, number of other devices are connected. Okay, here node 1 is connected. Node 2, node 3, this we call bus topology. In bus topology, there is a one main link is there, main cable is there. On this cable, uh, there are number of small devices are connected with each other. Now getting this point. So n devices are connected to a bus, then the number of cable required to communicate with them is only 1. But what happens to this cable or this features of bus topology? All the nodes are communicating via single line. Okay, so for example, if message of node A, like I want to communicate this message of node A is coming here on this line. Okay, and the message of B node also coming here. Okay, same line, na? Okay, again there are numbers of nodes, like here n nodes are there, so n nodes also means taking their message also coming in the same bus line or same cable. So what happens here, the all the message means one message, what is this one type of signals, so all the signals get collapsed with each others. Okay, so that we call the collision in bus topology. the collision is very tremendous or very huge. So if a network having traffic is heavy, then increase in collision in the network. For that purpose, we use a number of topologies like protocols like pure aloha, slotted aloha, CSMA, CD, CSMA slash CD. These are the protocols we'll discuss in upcoming lectures. What is that? Slotted aloha, pure aloha. These are the some protocols. Protocol means what? Rules to communicate via single cable or bus topology. Okay. And then another disadvantage of this bus topology is that if this cable get affected, means if cable get means what cut or get affected, so all the nodes communication will be lost. Is it clear? Is it clear? What is mesh? What is bus? All of you. Bus topology is clear. Okay, we'll discuss next. So remember that in bus topology we require only n. Uh, Only one cable is required to communicate with each other. Okay. Then another type of topology we are using here that we call ring topology. What is that? A ring topology. In ring topology, it is form of ring connecting devices with exactly two neighboring devices. One station is known as monitor station, which takes the responsibility to perform operation. To transmit the data, station has to log the token. After transmission is done, token is released and for the other station to use. When no station is transmitting the data, then token will circulating the rings. Okay, there are two types of token releasing techniques: early tokens release system. Okay, just after transmitting the data, and delay token releasing the uh, release releasing the token after acknowledging a receive from the this possibility of collision is minimum in this type of topology. If you are not understand, then I will explain what is this ring topology. And this is very simple topology that we are using in our communication in day-to-day life. Okay, this I will show you an example. What is that ring topology? As the name suggests, it is a ring. So we'll draw a ring. Okay, this is only ring. On that ring, like here, devices are connected with each other. Okay, how many devices are there? One. Here, this will be 1, 2, 3, 4, 5, 6, 7, 8, and the 9. Means what? 9 nodes are there. They are communicating via ring topology. So what happens in here? Just for example, this is a node A. Just calling a node A. This will be a B. This will be a C, D, E. Sorry, E, F, G, H, and this will be the I. So when I want to share information from A to C, like this place. From A to C, I want to share some information to A to C. Then we use, if I'm using a ring topology for that purpose. So what happens in ring topology? I'm sending a message like from A, I want to share the message. So I am active instead, means what, I am sending a message. Means for sending a message from A to C, I'm using this link. Okay, this message is go from A to B, then B to C. It will reach to the C point. So what happens in that message? I'm having a headers and tail. Means what, in that headers, having address of this nodes, address of this node. If the data is come to this node, it will be verified their data. Means what, header data will be verified. If header data not match with the content that having, and then it will forward to next. Okay, from A to B, then B to C, it will be forwarded. And then again on C platform, it will check it out, their headers and all details. If it is matched, then it will be accepting. So getting this point, what is mean by ring topology? Then I will explain what is that early token release and delay token release. Okay, so what happens then? What is monitor here? Look at here. In this session, in this A is a monitor, because A is monitoring all the requests. Means what, A is sending the data to C, and it will be circulating to all ports. Okay, means A is sending here also. It will also go here also. Okay, it will also circulate to all other ports in a ring. So A is work as a monitor. Getting this point, what is A? One station is known as monitor, which take the responsibility to perform the operations. Transformation means transportation transportation operation it perform. To transmit the data, station has hold the tokens. Means what, token means what, number. Like if you go in bank, if you're having a token, then if your turn is come, then you will go and collect your cash from cash counter, whatever the purpose you want in bank. And so that's why the token is picked up by A, so it will use by A only. A is work as a monitor. It will sing or whatever operation A will perform to perform, it will doing all operation. Then again, as soon as the operation is completed, it just release their token. Okay, as soon as his work is done, is release as token, that we call early release token. There are two types of token release technique. Early release token. Okay, there's just releasing a token just after transmitting the data. Whatever the data A want to transmit, just it transmit to all other nodes in the ring topologies, and then it is leave it. Got it? You got this concept? This we call early release of token. And what about delay token release? Delay token release means what? If A is releasing the data, A is releasing the data, and A get reply from C that data is received at a node C. So that we call delay token release. Okay, or that we call acknowledgement is received from the receivers. Okay, so in this topology, there is a minimum number of collisions. Like here, if you are using a bus topology, here too many collisions are there, because A is sending their data, B is sending data, C is sending data. So n number of sending their data through a means what, through a common cable. So it will having tremendous amount of collisions of data. But in ring topology, the collision of data is minimum. Are you getting this point? I think so. You understand all these points. All of you, please. Get this point. What is mesh topology? What is star topology? What is ring topology? What is bus topology? Is any kind of doubt regarding this topologies?